Hello, students. In this set of problems, we're going to look at the applications of derivatives. So something we really want to pay attention to in application problems is that we give thorough answers to the questions. So we always want to make sure that we include units and that we're really specific in regards to the situation that's happening. So the first situation we're going to talk about is me and my morning coffee. You know how I love my morning coffee, and the flow through the coffee maker, if you've been in the math office recently, our coffee maker has gotten super slow. And so we can think about the rate of flow into my coffee cup with this equation. And so this equation gives us ounces of coffee per minute. Sorry, the equation doesn't give us ounces of coffee per minute because that would be my rate of change. This equation gives me an ounce, how many ounces at a certain minute. So first I want to think about this equation. So this equation I'm going to rewrite just to help me think about the graph. So I'm going to call it negative 16e to the negative 0.4t plus 16. So this is an exponential graph that's been reflected across both the x and the y-axis. So normally exponential graphs look like this, but I'm going to reflect it to look like this and reflect again, so it's going to look like this. So imagine all that in your head, and our end shape is like this. My asymptote is going to be horizontal. And then I want to think about my y-intercept and my x-intercept. So b of 0, well, anything to the 0 is 1, negative 16 plus 16 is 0. So both my x and y-intercept are the same, and that's at 0, 0. My asymptote as t, this is my t is the time in minutes. My y-axis here is my ounces of coffee. And if I think about t going towards infinity, well, e to the negative infinity is going to approach 0. 0 plus 16 is going to approach this line 16. So here, this is going to be b equals 16 as my horizontal asymptote. But what we're first asked to find is b prime of 5. So I'm going to start by finding the first derivative with respect to t. I know derivative of e to the something is e to the something, but I have to do chain rule, so derivative of the something. I'm going to do negative 16. Derivative of my exponent is negative 0.4, so that's going to give me 6.4. And then e to the something, so that negative 0.4t will stay the same. Derivative of 16 is just 0, so I'll have nothing there. Let me rewrite this so it looks clearer. So 0.4t. And now b prime of 5, well, I'm going to plug in 5. Over here on my calculator, I have created this graph. So here's my graph. This value here is when I went into my calculator menu and I went into Analyze Graph, and then I did dy dx, and I entered my position as 5. So I just typed in 5 and got 0.886. On the main screen, my calculator screen here, I went into my menu and calculus and found the derivative at a point. And we can see the equation that I typed in here. Because I've already got my f1 typed in, I just put in f1 of x and I evaluated that at x equals 5. I got the same value. So that was 0.866. And now, normally I would write the units here, but they've asked the units down here. So let's think about this. This value, b prime of 5, is going to be my slope when the t value is 5. So if I drew in the tangent line here, the slope of this is going to be rate of change of ounces per minute. So we've got ounces per minute. And the reason I know is because it's a slope, which is rate of change, which is my delta b, which is being measured in ounces here, over delta t, which is minutes. So the meaning of b prime of 5 in the context of this problem. So the context of this problem is coffee going into a coffee cup. So my value here, I'm going to say the meaning of this is that, why are you not giving me a text box? All right, so the instantaneous rate of flow of coffee into Miss S's cup at 5 minutes is 0.866, let's go 866 ounces per minute. And that's because it's positive, so the rate of flow of coffee into my cup at 5 minutes is increasing. I want to be specific here, like I said at the beginning, so specific. So I'm going to use very specific language. It's increasing at 8.66 ounces per minute. So I want to make sure that I'm including value, description, and units. Let's apply that to this next problem down here. So this next problem talks about myself and Miss Patali roasting marshmallows over a campfire and thinking about the temperature of our roasting stick as we get further away from the fire. So the tip of our stick is in the fire, it's 100 degrees. As we get further out of the fire, so 8 centimeters out of the fire, the tip of the stick is 55 degrees Celsius. So estimate T prime of 4 using the table. Well, I know 4 is going to be in between these values here. I know that T prime of 4 is a rate of change, so my T prime of 4 estimate is going to be approximately equal to my slope between these 2 points. So 70 minus 93 over 5 minus 4, 5 minus 1, I was thinking ahead. That's going to be negative 23 over 4, which is equal to, let's see what that is, divide by 4, and then I can control enter, 5.75. All right, sorry, negative 5.75. I know it's going to be negative because as I saw, my temperature is decreasing as I get further out of the fire. So let's think about our units here. So the value T prime of 4 in the context of the problem. So let me type this out. All right, so when this, let's get that out of bold, the stick is 4 centimeters out of the fire, the stick's temperature is decreasing at a rate of approximately 5.75. All right, so my rate of change here is going to be degrees Celsius per centimeter. So I've got rate of change of my Y value over rate of change of my X value. So degrees Celsius per centimeter. And it's approximate because I don't know the actual value, so I had to make my best guess.